10.4 is going to introduce us to box and whisker plots, which are ways to represent data sets along a number line by using 5 numbers from the data set. So we have the least value or the minimum, we'll use the greatest value or the maximum, and then way back from Unit 9, when we talked about finding the interquartile ranges, you're going to need to find the first quartile number, the third quartile number, and then the median for the data set. So the value of a box and whisker plot is that it shows the variability of the data set. So it shows if the data is skewed right, it shows if it's skewed left, or if it shows if the data is pretty much situated evenly throughout the data set. So these 5 numbers, the least value, first quartile, median, third quartile, and greatest value, that make up the plot are called the 5-number summary of the data set. So let's jump right into looking at a set of data. So we've got ages of spider monkeys at the zoo, and below are their ages. And then our first thing to do with this data is to put the data in order. And then we'll find the median and the quartiles from that. So if we put this data in order, we'll get the following numbers. And then, as always, when you are recopying, to put them in order, make sure you have the same number of data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Okay, so that's just kind of double checking to make sure that we didn't forget one, which could be very easy to do. So when we find the median, of course, we are just going to mark off low, high, and I'm going to do this in pencil because I'm going to end up marking these numbers off a couple of different times, and I don't want to completely obliterate the number. So the first one we find is the median of the entire data set, and since it's 30 and 30, I'm going to split the difference, and 30 is our median. I'm also going to need to know the minimum, and I'm going to need to know the maximum. And then once I've identified those 3, I can identify numbers within the first quartile range and the third quartile range. And so if this is my halfway point here, I'll now find the median in that set of data and the median of the upper set of data. So once again, I'll cross them off from low, high. I end up with 2 in the middle. And the median number between 20 and 26 is 23. And cross these off low, high again. And the middle number between 33 and 35 is 34. So my 5 data points that I have here for my 5-number summary are 14, 38, 30, and then my first quartile is 23, and my third quartile is 34. In a box and whisker plot, these are the 5 numbers that will get plotted. So onto this number line, I am going to represent the numbers. So I need to have 14 represented all the way up through 38 on this graph. So I'm going to go up by 2s. Otherwise, it would be a really tight fit. So if I do 14, 16, 18, 20, and 38. And now I'm just going to plot where all 5 of these would be on this number line. Grab a different color pen here. So I know 14 is my minimum, 23 is a data point, 30 is a data point, 34 and 38. Okay, so the box in a box and whisker plot is going to surround or encompass, I guess you could say, the first quartile range number, which in this case is 23, and it's going to end at the third quartile range number. So this is the first quartile range number, and this is the third, and this, of course, here was your original median for the entire data set. So these are 3 of your data points. This was 23 and this was 34. The remaining 2 dots get connected with what they're called a whisker. Okay, so my 3rd quartile gets connected to my maximum, which is 38, and my 1st quartile gets connected to my minimum, which is 14. Okay, and so that's how we can use that data to create that box and whisker plot. And once again, it's just a nice way to look at the data to see if it is skewed one direction or another direction, to see if the data has any outliers, or to see if it's pretty good data without having anything really far off one way or the other direction. All right, another set of data here. So we've got a group of friends who spent a certain number of hours online. If I rearrange this data, which is what I need to do first, from low to high, I've got 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 4, and 6. So once again, I work to find my 5 data points. I've got my minimum and my maximum, and then I'll cross off with pencil to find my median. And I like it when it's an odd numbered set of data because you don't have to find the average. So there's my median. And then I'll take my pencil and just cross them off the other way to find the first interquartile range, which is 1. And then my 3rd quartile range, which is 3. So I have my minimum, my maximum, the median for the whole data set, the 1st and the 3rd. So if I were to put this on a number line, my number 9 needs to represent from 0 to 6. So in this one, that's easy. I can just go up by ones. So 0, 1, 2, 3, 4, 5, and 6. And I'll plot my 5 plots. 0, 1, 2, 3, and 6. My box gets drawn around my 1st and 3rd quartile. Here's my median. And I have a really long whisker extending to the right, which we'll talk about that in just a minute, and a short whisker off to the left. Okay, when you've drawn your box and whisker plot, you might see something like this, where the data isn't nice and symmetrical, where the whiskers aren't the same length. And if that's the case, just like we had in 10.3, you are going to have a box and whisker plot that can be skewed left, skewed right, or symmetrical. In this case, if the tail is longer on the right, which it is, we are going to call this a skewed right graph. It means that while the tail is longer, it means most of the data is on the left. Okay, so if we were faced with something, and I'll just draw one up above here, if we had something that looked more like this, kind of just like an opposite image here, I would connect these. There's a short whisker on the right and a long whisker on the left. This one would be a skewed left because that tail is longer on the left. So this is a skewed left because the tail is longer on the left, or the whisker is longer on the left. And this one is a skewed right because the whisker is longer on the right. Skewed right means most data is on the left, and a skewed left means most data is on the right. And then of course, if you end up with something that looks like this, where everything is evenly spaced, you would say this was symmetric. where all the data, or the median is in the middle of the box, and then the whiskers are the same length. So just like in 10.3, we have skewed right graphs, skewed left graphs or box and whisker plots, and then symmetric box and whisker plots. Okay, and there was another graphic that will show you what we just talked about there. The last thing we are going to discuss is what happens when you have two box and whisker plots above each other in the same number graph. You can actually do quite a bit. You can compare some information to each other. So this says the double box and whisker plot, which this is double because it's showing two, represents the prices of snowboards at two stores. So store A, we can see that we have snowboards that cost anywhere from $150 to $450, with of course some costs in between. And then at store B, we have snowboards that cost anywhere from $250 all the way up to $650, with of course some in between. So if we can look at each one of these and identify the shape of each distribution, store A, it's pretty obvious. Our whiskers are the same length as each other. So this one we would say was symmetric. And store B, I can see that the right whisker is longer. And so this one would be a skewed right. Once again, meaning most of the data is on the left. Okay. So which store's prices are more spread out? Well, that's the beauty of the box and whisker plot, is you now have a visual where you can see which of the data is spread out and which of the data is nice and compact. And so store B, I think it's pretty clear that we have all the way from $250 to $650, so we have a range of 400 different price points. And here at store A, their price points only range $300. So if you were looking for the greatest price ranges, or then you would go to store B. If you were looking for something that had pretty consistent pricing, you would want to go to store A. Let me just check my other page here. And there was nothing else left in this lesson. So just remembering again, box and whisker plots show variability in a data set, and you can compare two different things in one box and whisker plot simply by putting the data, stacking it on top of each other, and then you can easily see, like in this case, which data is more compact and which data is more spread out.